Hello friends, welcome back to my channel. Here we will learn how the Java Stream API can be used to generate a perfect number series. So the question is, what is perfect number? So in order to understand the perfect number series, let's take a look at what it is. In mathematics, a perfect number is the sum of all its proper divisor, excluding the number itself. A proper divisor of a number is any divisor less than the number itself. For example, the proper divisor of 6 are 1, 2 and 3. Since 1 plus 2 plus 3 is equal to 6, 6 is a perfect number. Another example I can give is like 28. 28 has a proper divisor like 1, 2, 4, 7, 14, and if you sum it up, it will be equal to 28. So 28 is also a perfect number. Okay, so let's dive into the code. Let's see how we can generate a perfect number series using Java Stream API. Okay, so before solving this perfect number series question, I just want to remind you that I have asked one question regarding functional interface annotation in the previous videos, and I would like to answer for that. The first thing is I ask is whether it is mandatory to use functional interface annotation to create a functional interface. The answer is no. Why? Because now you can ask question, if it is not mandatory, then why this annotation is there in first place, right? So there are several reasons for that. It provides the compile time safety, right? Like if you accidentally add more than one abstract method, then compiler will throw an error. This prevents unintentional mistakes, right? Like as you know that functional interface will have only one abstract method. It can have a default method, more than one default method and a static method, but abstract method should be only one. So if we use @functional interface, it provides the compile time safety. Also, uh, it it is used for like code clarity and documentation. Using this annotation make it explicit that the interface is intended to be a functional interface. So this improves code readability, and you can say as it serves as a documentation for other developers. Okay, so these are the advantages of using functional interface annotation uh, for that. And why we use functional interface? Because as I said earlier also, that it enables us to use with lambda expression. Okay, we can use lambda expression which provide a concise ways to express instances of functional interfaces, which also simplify code and improve readability. It it helps us to reduce boilerplate code. Uh, Also, it provide a functional programming. Okay, uh, so these are the features which is useful when we use functional interface. Okay, so now let's move to the perfect number generation, and we will delete this old code now. And the problem statement is we have to find the perfect number, okay, using Java string. Okay, so this is the thing. So here we need to do two things. First thing, we need to check whether number is a perfect number or not. As I said earlier, the perfect number is what? All the divisor, it is divisible by all the divisor except its own number, and perfectly divided by its all divisor, and sum of those divisor is having equal is equal to the number itself. Okay, so first thing you should understand that perfect number is very rare. It is not very common. Okay, so like first two number is like 6, 28 is the perfect number, and then after 28 it's really go beyond that, like 438 something. Okay, so So here we will do before generating the series, we need to find whether the number is perfect or not. So we will create one method again, which we will use as a functional interface or method references. So like public static, uh, we will return true or false whether number is perfect or not, and here the number is method name will be we will be passing number, and then we will be checking. So first thing is, here first thing what we do is we will check whether number is less than 6. If it is less than 6, we will return false, because as you know that number if less than 6, it is not a perfect number, right? So any number which is below 6 is not a perfect number, so we will return false. And then we will do the stream here, stream dot iterate again. Here again we will give the starting number, which can be 1 here, and then here we will just increment the number by 1. Okay, and we will limit this by and we will limit it below subtract the maximum number is, like, suppose if it is 10, so we don't want 10 divided by 10, right? So what we do is we will we will use only the number which is less than that number for division. Okay, so here we will do filter, and here we will do is what, again we will passing n. Here what we do is we need to check whether number is divisible by that or not. So here we will do like check. If it is divisible, then we will do reduce, and we will use integer, and we will do sum. So again it is a method reference. Okay, so what it will give us, it will give us the optional integer. Okay, and here we will get this store in the, now we will check if number is equal to total dot or else 0, then return true, right? Or else return false. Okay, so this is how we will find whether number is perfect or not. So just to explain you better, we are passing any number, like suppose 7 we are passing. Okay, and what we'll do is we will iterate from 1 to 7, 1 to 6. Okay, and each number, when like suppose first number is 1 here, we will try to divide it with number 7. If it is equal to 0, means it is perfectly divisible, then we will add the sum, and all the number which is divisible by the number perfectly, we will add the sum, and we will check whether that sum is equal to that number or not. So here we have used or else because it is an optional integer, and you know optional integer means it may be it can throw a null value also. So we have used optional here, and or else means we are providing the default value in case of null. right? In case of null, it will give 0. So there is a we are avoiding the null pointer exception here. Okay, we are passing the 0. So it will check whether number is equal to the sum of the divisor, and if it is true, then it will return true, otherwise it will return false. So in case it is true, that means it is a perfect number. Okay, so this is how we will able to find the perfect number through stream API. Now what we do is we need to find the series also, right? So what we can do is we can again do the same thing here, stream dot iterate. Okay, again we will pass the initial number, like suppose 1 here, and plus 1 to iterate, sorry, and then uh, we'll filter only those number which is perfect number, right? So here we are passing this method as a reference to filter out only the perfect number, and then we'll limit it also, because this is the time complexity to find a perfect number series is like m into n. Okay, so it will take huge time, and it may crash your system also. So, and it is very rare to find the perfect number, because after 28 it goes to 436, and in between you have to do so many division and so many calculations. So it is very time consuming, time complexity is very high here. So we will just limit it to 2 element. Okay, just to check whether our logic is right or not, and then we will collect it into list. We can do list also, or we can print directly, it's totally on you. And then whatever is like list integer, we will get like uh, perfect list. Okay, and then we can print it. Okay, so I hope you understand what we have done here. We have created one method, public static, and in that method is we are passing the number. So like when we iterate from 1 to n, it will pass each number in this filter, and it will check whether that number is perfect number or not. So if it is perfect, then only it will move forward, and it will be collected into the integer, right? So this list will give you the list of all perfect number. And here what we have done is we are passing each number, and we are checking whether that number is perfectly divided by that number, and if it is giving zero remainder, then we uh, do the sum. Okay, so and in last we are checking whether the sum is equal to the number, so it will tell us the whether that is perfect number or not, right? So let's see whether it's working fine or not. So it's working fine here. Okay, so you can see 6 is the perfect number and 28 is the perfect number. Also in this case we can use a parallel stream uh, like this. This will help uh, this will help us to this will help us to do the processing in different thread, so it will be little faster. Okay, so yeah, so that's it. So I hope you understand how we can generate perfect number and how we can find perfect number. uh, Thank you. We'll meet in next video. Thank you.